Hello everyone. So today I'm going to be performing the same analysis in both Phoretix 1D and ImageJ to show you the differences between the programs and the benefits that Phoretix 1D can bring to your analysis. Hello everyone. So today I'm going to be performing two analyses of the same gel or blot image, one within our Phoretix 1D software and another in ImageJ, which is obviously the open source free option that is widely used in academia and sometimes in industry as well, to try and answer a question that we get very frequently, i.e., why would we pay for your software when we can use ImageJ to do quantification for free? And our answer to that is, how much is your time worth? So I'm going to show you exactly how quickly it is to get results from your gel or blot image in Phoretix 1D, and then perform the same analysis to try and get the same results in ImageJ and compare the time taken for both. Now, obviously, as an employee of Total Lab, I am somewhat biased, but I will include the tutorial video that I've used within ImageJ within the link, so you can see that I've done everything as per the tutorial, and the time taken to do the analysis in both pieces of software is the same based on the parameters that I've used for analysis. So this is just a tutorial image that comes within Phoretix 1D for you to try out the software if you did want a free trial or something like that. As you can see, I've just opened the image within the software and it's already been converted to grayscale, so it's ready to quantify. If I come through and move to my lane section next, I can either use the automatic lane detection function there to pull out my lanes, or I can manually define my lane boxes and say I know I've got 10 lanes in my gel, and put my box on top to define those. But if you do use the automatic lane detection, obviously that's a much quicker way of defining your lanes and getting closer to your results. If I come down through into my background removal, I can select one of the built-in background removal techniques, which are industry standard, so will be available in ImageJ as well. However, if I just click here, I get this graphical representation of how my different background settings are going to impact my results and the intensity of my bands. So I can select my background removal technique and strength appropriately and quickly. If I have used a molecular weight ladder within my experiment, I can insert it in this step, left click there, and then I get all of my bands appropriately labeled, and then all of my other bands in my other lanes, once they're detected in the band section, will then be given the appropriate molecular weight based on the ladder that I've used. We've also got the quality control of the molecular weight ladder by graphing the function here. So each of these orange points is the point of the band that has been used for detection, and then the green line between all of those points is the mathematically extrapolated kind of line of best fit for when you want to interpret bands that don't fall exactly on one of the marker bands that you've selected, i.e. within these green sections, this is where if a band existed, the software would extrapolate from the known values to try and get as close to as possible to the molecular weight of that band. So it's a mathematical calculation that determines the molecular weight for those bands, rather than saying it lands exactly on the 500 kilodalton step, so I know that this band is 500 kilodaltons. If I come down to the band selection, the automatic band detection mode, click on detect bands, and then I can get my bands already quantified. Now you may need to remove some or adjust the settings to appropriately detect the bands that you want to detect within your image. So we've got a few detection presets, but you've also got full control over the strength of the band detection mechanism within the software there. If we want to perform any normalization, we do that within the normalize mode. Quantity calibration for unknown samples. If you've got standards built into your experiment, we can mathematically extrapolate the quantity of DNA, RNA, or protein within that band based on the known values you've included in your experiment. And then finally, we can come down to the results section and turn on with the results that we want to see, and then export those to a CSV file for Excel if you want to do further processing in Excel, or we can copy and paste them if you want to copy and paste them into a different piece of software. you're doing any kind of coding, MATLAB, Python, anything like that, you can copy this table into there. And we can, of course, generate the PDF report, which is a more formalized report for things like sign-off. So that would be the entire workflow process to get measurements for bands within Phoretix 1D. I've done more complete demo videos that are available on our YouTube channel about all of these different modes, but I just wanted to highlight how quick it is to get from image to results within Phoretix 1D, and the kind of options that you have for exporting results once you've performed that analysis. So the main benefit for users in using Phoretix 1D versus ImageJ is that it removes a lot of the manual steps. You don't need to remember all of the manual steps because we've got this guided workflow that will take you through every step of the quantification process. And we've taken a lot of the work away from you and put it in a very neat, easy to use package, which can drastically reduce the amount of time required for you to analyze your gels or blots, especially if you're doing lots of them. We also have the ability to automate a lot of this process using our protocols function. And again, there's a video that goes more into depth about how to use the protocols function on our YouTube channel. So now what I'm going to try and do is attempt to analyze the same image in ImageJ and get what I got from Phoretix. Maybe not the exact same measurements, but measurements for all of the bands that are within the lanes within my image here, in a format that I can do something with them. Now I know ImageJ doesn't have any built-in kind of PDF reporting, so the only comparable mechanism is measurements that I can take into Excel. So that's why I've got a blank Excel document open in the background there. So I've been watching a few tutorials on YouTube on how to do this. So obviously in Phoretix 1D, it's very you get a very guided workflow. It takes you through each step because it is designed for a specific purpose, whereas ImageJ is a completely open kind of sandbox image analysis tool. So you'll see here that I've got the steps written down that I've taken from the tutorial to try and process this image. If you were doing this in the lab, you would need to either know these off by heart or have them written down as I've got them written here in an SOP or something like that. Again, in the Phoretix 1D workflow, the user is very much guided through it. So the first thing the tutorial asked me to do was just to check the brightness and contrast levels of my image and make any adjustments if necessary. Now, when you open up an image in Phoretix 1D, it is actually processed in the background to try and auto-calibrate the contrast and brightness for the image to try and present the best image to the user. But if you did want to override those, you do have these comparable tools within Phoretix 1D, and I'll show you in another one of my tutorial videos how to access those and change those. I'll just brighten this up a little bit just to get the maximum, just so I can see my band edges, but I think this is pretty much set, this image, so I'll consider that done. And now what the tutorial asked me to do is remove the background of the image. So for this, it uses the rectangle tool, and it says, you know, select an area of your blot or gel that you would consider empty or to be background. We have this feature in Phoretix 1D under the background modes. We call it image rectangle, but this is just a manual way of doing this. So select the region of interest, analyze, set measurements, click on mean gray value, OK, then analyze again and then measure that. So it's telling me the mean gray pixel value within this square is 27.758. So what I've then got to do is then process this image and subtract a grey value of 27.758 from all of the pixels within my image. I've just realized that I had this area still selected, so it's not done the whole image. So if I select none, try that procedure again, subtract. So you'll see my image has changed, it's slightly darkened because we've subtracted some pixel values from each pixel. So that should be the background removal step complete. Now, background removal via this technique assumes that the background level across the entire image, left to right, up to down, is exactly the same. There's been no changes in, you know, there's not some areas that have been blocked better than others. There's not any kind of lighting discrepancies within your gel duct device that means there's uneven lighting across your gel. All this does is a constant background subtraction from every pixel, but you can see down at the bottom here on the bottom left of the image, I would consider this area to be background, or certainly I don't want to measure these as bands because I don't think they are signal. But if I come across to the right, these areas which are still background are now darker than these areas. So if I use a constant value, do I use this one or do I use this one? Using an adaptive background removal technique such as rolling ball, which we present in Phoretix 1D, would allow you to compensate for both of these scenarios. As it stands now, we're just going to have to use, I believe, built into ImageJ. I'm only using standard ImageJ. There are plugins available potentially that could solve this. But at the moment, I'm going to have to assume an even background level, which in real life is not always the case. So I've subtracted a background, and then so now I need to start defining my lanes for measurement. So if I use the rectangle tool and try and define lanes, you can see I've got a bit of a problem with this image in that my lanes don't go straight up and down. So if I try and fit them within a rectangle, I end up chopping off some of my lane or incorporating other lanes into my analysis. So I'll see the polygon tool might be a better tool to try and define my lanes here. So grab the polygon tool and I'll just draw around this lane here. So then I'll come through and use the built-in gels function and select this as my first lane. Right, okay. So it appears within standard ImageJ you can only use rectangular shapes to define lanes, which causes a bit of an issue when you've got an image like this. So either I would have to repeat my experiment hoping for completely vertical, straight up and down lanes that would fit within a rectangle, or and that might not be possible if I'd used the last of my sample for this experiment, for example, or I have to be content with kind of chopping off sections of lane somewhat arbitrarily. But nevertheless, I will select none. I will persevere with the rectangle tools for now. But as you saw in the previous example, both in Phoretix 1D, the automatic lane detection did accommodate for lanes that are not perfectly straight, and the manual lane addition and manipulation tools within Phoretix 1D also do not require straight vertical lanes. So that would be something you can do in Phoretix 1D that it doesn't appear that I can do in ImageJ here in terms of processing. Nevertheless, I'll run through the rest of the procedure. So analyze gels, select first lane. So that's fine. Now I've got a rectangle. Analyze gels, plot lanes. Right. Okay. So what you can see here is actually what we are seeing here as bands are actually being represented as kind of troughs or low areas within our lane profile. And this tells me that I need to invert this image. Now, you can invert images in Phoretix 1D, and because of the image view when you open an image in Phoretix 1D, we would have noticed this much sooner, that we needed to invert our data. So if I just close this, and then just reset this, and deselect everything. So I want to invert the entire image. So now when I define my rectangle and set it as my first lane, and then plot the lanes, yeah, so I can now get my lane profile as I would expect to see it with peaks. So the next step is to draw lines under my bands to define them, to define where the cutoff is for measuring volume. As you can see here, these areas, the data shows that these areas I would consider to be background noise. that hasn't been subtracted using the background removal technique that was over on this side. And you can see that this background value is somewhat lower than some of this background value and this background value and the area between these peaks here. Again, this is the downfall of applying a constant background value in terms of numbers to a lane that might not have a constant background value in terms of the image. Something like rolling ball would accommodate for these areas and allow those to be subtracted from your data. But I will continue nonetheless. So you can see here I'm drawing lines underneath to define where my bands are. This is very much a manual process and it's very subjective. Like, would I draw them diagonally like this, or would I draw them just straight across like that? I may do it one way and someone else may do it another way, so it's quite hard to replicate this between different users and get similar reliable results because it's not exactly standardized. So I'll come across and I'll define my peaks. And then the next step is to get the one tool and then get that for volume. So analyze gels, label peaks. Analyze gels, label peaks. So I'm getting some results as I do this. But as you can see, it's not. I see. So we just left click within this. So as you could see before, when I was clicking on peaks, if I've not defined the line quite completely across, it ends up selecting this entire area as the area under the curve, the area under the peak. So then if I come across and then gels label my peaks, so you can see for some reason I've got 100% on all of these, even though I've labeled them as peaks. So it seems to be very tricky to try and do a whole lane's worth of peaks at once. I'll try adding an additional lane. So if I come back, so if I come through Analyze Gels, select Next Lane. If I then have, if I define a second rectangle with my lane in, and then Analyze Gels, select Next Lane. So I have to come across right, okay, I see. So I have to so if I want to continually select lanes, if I want to select all the lanes within this image, I would have to manually come across and define all of those. And now I've ended up with, if I click delete there, now I've ended up with select none. Okay. So then if I draw another rectangle, then can I select that as the next lane? Right, so all selections must be the same size. So again, that's not a prerequisite that's required in Phoretix 1D. You can use lanes of different size. I'm not going to attempt to add every single lane here because I can tell it's not going to make for a very interactive video. So if I come across and then replot, okay, don't save, select first lane, plot lanes. See, now we've ended up in a situation, hang on, let's just reset this. So we'll set this as first lane. Rectangular selection required. Now I can make a rectangular selection, but I think I'm going to get the same error that I got before, is that it might not be exactly the same size. Select next lane. So I don't know how you're meant to try and select all the lanes that are within this image. Nevertheless, let's go. So don't save those. Analyze, gels, plot lanes. Let's reset that. So analyze gel. So draw a rectangle, define that as my first lane. And then I suppose I can't copy and paste. So there we go. So we've got the lane back. So as you can see, it's already taken me much longer, and I've not even defined one lane yet. But if I come across and do all of this, I just want to get one lane's worth of results. So come across, I'll make that a little lane there. And try and get some data for this. So there's one peak, there's a second peak, there's a third peak, there's a fourth peak, fifth peak, sixth peak, seventh peak, eighth peak, ninth peak, 10th peak, 11, 12, 13, 14. So now I have my results. So this would be similar to what we would export to a CSV. This is what we would consider to be intensity, volume. It's called area here, but kind of considered to be volume. So I can now go and copy and paste these to my Excel document and then do, okay, edit. So there we go. So I can then copy this into my Excel document and then perform things like my quantification or my normalization to housekeeping gene or anything like that. But that's the time it's taken me to do one lane within the software. I'm not going to go through the rigmarole of attempting to perform any kind of molecular weight calibration or anything like that. I think I've kind of proven my point that Phoretix 1D provides you access to your results much quicker and much more reliably than ImageJ can do. And it's much more robust when shared between different operators. You can be sure that people are using the same settings, using the same kind of automatic band and lane detection settings, and you can see all of that information produced in a PDF report, whereas here all we get out is kind of raw measurements that then have no way of being verified back, because if I open this, I can guarantee if I open this image again and try to repeat this analysis, I would probably get different results because I would draw the rectangle slightly differently, or I'd draw my background subtraction rectangle in a slightly different area or something like that. So that is a brief comparison of our Phoretix 1D software versus the industry standard ImageJ analysis techniques for Western blot or electrophoresis gel quantification. As ever, thanks for watching, and if you'd like to try out a free trial copy of Phoretix 1D to compare to ImageJ within your lab with your images, please check out the links in the description below.